Hi guys, this is Mrs. Gastler, and in this video we're going to talk about potential energy, but we're going to start by talking about work. Now remember that work is force dotted with distance, and that this is a dot product because force and distance are vectors. And when you do the dot product, what you're doing is you're taking the force times the distance times the cosine of the angle between them. And what we're going to do, because we're looking at potential energy, is we're going to look at the amount of work that it does, that you do when you lift something vertically. Okay, so we're going to go up. And the amount of work that you do to raise something up vertically is against gravity. So we're going to look at the work done by gravity. And the work done by gravity is going to be done by the force of gravity, so we're going to put an FG there. And when we're going straight up and down, the distance that we travel, D, is going to be in the same or in the opposite direction, so that the cosine of theta is going to be the cosine of 0, which is going to be 1. If they're in the opposite direction, then the cosine of 180 is going to be -1. So it depends on whether or not it's going up or down. So if you're making something go up, then the work done by gravity is in the opposite directions, because gravity wants the object to go down. And if the object is falling, then the work done by gravity is in the same direction as the distance that it's going. So if you're going up, gravity pulls it down. So the work done is negative. That means that gravity is trying to take things away from it, and if it's going down, then gravity pulls with it. Gravity pulls down, so then gravity is going to do positive work on it. And we'll talk about what that means in the next objective. Just a little bit more. And so the work done is positive, so that's where we're getting the positive and -1 there. So I'm gonna kind of drop this off, and we're gonna talk about how it's 1. And so the work done by gravity is essentially the force of gravity times the distance that it's going, provided that we're going straight up and straight down. Okay, and we'll talk about some other interesting things about that in a little bit. And so the force of gravity on an object that has a mass of m is going to be m times g times the distance that it travels. And if we're in some coordinate plane where this is y and this is the x, and we're just going straight up and straight down, then the distance that it travels is going to be from some, let's say it's going down or up. Let's say that this is some initial and this is some final. Then it will be the distance that it travels is some difference between those, right? So this is mg final minus mg initial, like that. And this is where we get our definition of potential energy. Hang on, let me add in here. Gravitational potential energy. And that is UG. Okay, why do we use U? I have no idea. I have no idea why they picked U for potential energy, but U stands for any potential energy. There's other potential energies out there. We use U for all of them, and then a subscript to distinguish between them, G for gravitational. So UG is M times G times some sort of height, okay? And here we're using Y. We could use any sort of height, okay? Some sort of relative height to some 0. Interestingly enough, you can pick 0 to be anywhere, and you can put it on the table, you could put it on the floor, you could put it in a tree, you could put it at the center of Earth. It is totally up to you where you put 0, and in physics we put 0 wherever it makes something easy. Okay, we like to make 0 to be a relevant. We like to put 0 in an equation so that it falls out, actually. So we say that it's arbitrary. Arbitrary means it's up to you. Arbitrary means it doesn't matter. Doesn't matter. It's up to you. Pick something that makes it easy. Okay, 0 is arbitrary. We measure it relative to something where 0 is gonna fall out of the equation somewhere. Okay, or it's gonna make something fall out. So if we pick one of these to be 0, that's usually a good idea. Okay, sometimes we can't, and sometimes we need to, and sometimes we don't want to. It really just depends. It all works out the same mathematically when we're talking about differences, because this would be U final, UG final, and this would be UG initial, and the difference is still going to be the same regardless of where we put the initial and final. Okay, so the work done by gravity is going to be the difference in the potential energy. Okay. Now this is valuable because when we're talking about work and how work changes the energy of something, understanding that the work done by gravity changes the potential energy of something, we can pair that up with that work kinetic energy theorem that we were talking about previously. And when we understand that the work net also changes the gravitational potential energy of something, when we put these all together, we get some really cool stuff taking place. And that'll be in a future lesson. So right now, though, work done by gravity happens to be the change in potential energy. Okay. So interestingly enough, work done by gravity changes the potential energy. Well, where does that potential energy go? Well, it turns into things like kinetic energy, or sometimes heat, depending on what else is going on. Okay. So that's all I have to say about gravitational potential energy. One of the things that I want you to understand about gravitational potential energy and potential energies in general, let me add that in. A lot of times in middle school, when middle school teachers talk about potential energy and kinetic energy, they talk about them like they're opposites. Like kinetic energy is the energy of motion, and potential energy is the energy that you have that's stored up, waiting to become the energy of motion. But you can really have both at the same time. Potential energy is the energy that you have because of your position, okay, relative to something else. And in gravitational potential energy, it's the energy that you have relative to something that has a gravitational field, okay, so like Earth. The sun and Pluto and anything else, like me, I have gravitational field also. Mine is really tiny because I'm way smaller than Earth. And so you don't really notice it, but I have gravitational potential energy field too. But the height is that position part, right? So that's the position. And if you really recognize, you might see potential position. You see how those have some similar letters going on there. That's what we're talking about when we talk about gravitational potential energy. So an object that is flying up high in the sky has both potential energy and kinetic energy at the same time, because you can't have both of those at the same time. It's not one or the other. You don't have potential energy and it's waiting to turn into kinetic energy. You can have both at the same time. And you can have one but not the other too. And you can have both. So it really just depends on the situation and what's happening, not on one or the other, okay? If you have any questions about these, make sure you ask. I don't have any examples that I want to go through because they're really, really, really simple, and there aren't very many examples in the book, and I don't want to steal those away from the textbook, okay? But if you'd like to go through some, let me know. Thanks for watching.